Ladies, gents, welcome to our second lesson in the quadratic equation situation, we'll call it. We're going to look at 3.3, which is word problems using quadratics. Another way of looking at it is application, or applying quadratics. It is March 4th, 2020. Mr. Benjamin here. Always having a positive mindset, so my graph is kind of opening up, but that looks ridiculous, so I'll just keep it as a happy face. So, learning goals for this lesson. We're going to review the quadratic equations, their standard form and factored form. We primarily use factored form, and we'll look at standard form a bit later in the series, but for now we're just going to look at the factored form. We're also going to apply quadratics to word problems. So, knowing math, having the knowledge of it is great. However, it's almost irrelevant unless you can apply it. Understanding how things work is very good, but you need to be able to apply the information to relevant situations. Doing a quick review of what quadratics are. Now, for visual, keep in mind, we have linear relationships, which are straight lines. Doesn't matter what direction they're going in. These could all be linear relationships. In fact, these would be the same linear relationship, but whatever. Our quadratics are going to have a different shape. They're going to be parabolic. So they're going to look like that. And we can have quadratic relationships with 2 zeros, or x-intercepts with no zeros, or x-intercepts, or 1 0, or x-intercept. Anyways, getting rid of those circles. We have two different forms for our quadratic equation. We have the standard form, which is y is equal to ax squared. Keeping in mind the squared means it's second degree. And that second differences are the same, or constant. And our b value is just bx, and c, which is just our constant. Now, a, c, b, they're involved in shifting the equation, but again, we're not going to look at that right now. We're going to look at factored form. When we have factored form, we're taking that ax squared bx plus c and turning it into a factored equation, which is right here. So this a determines graph orientation. So if it's positive, the graph will open up and make a happy face. And if it's negative, the graph will open down and be a sad face. Well, that parabola looks terrible, so I'll draw it again. Kind of like that. These values here are x values, or s and t, I should say. These determine the zeros of the equation. And the zeros, as we mentioned before in this diagram, are where the parabola passes through the x-axis. So you can either have 2, 1, or none. And that is very important when we're determining the other factors. Let's get into example word problems. Our first example, the Dufferin Gate, not entirely sure if this is a real thing, someone can look that up for me later, is a parabolic arch. So, if I were to draw a quick little grid here, I'm assuming it looks something like this. Okay, because otherwise, an arch wouldn't open upside down. That wouldn't make much sense in terms of just the way it looks, right? It is approximately 20 meters tall and 22 meters wide. So this distance here, from here to here, is 22 meters. And this distance here is 20 meters. That is a very important point. That's known as our vertex, right? Okay. Sketch a graph with the base on the x-axis 4 units to the left of the y-axis. Label x and y-intercepts and vertex. Okay, well, sorry, just x-intercepts and vertex. Okay, so I'm going to go to another slide and have a larger grid. We need to go back and look at the information. So we know that it's 22 meters tall and 22 meters wide. So I'm going to write that down over here. 22 meters tall, 20 meters wide. Did I get that right, or did I flip that? 20 meters tall, 22 wide. You see I got that wrong. I made a mistake. I got to correct that. All right. And we also know when we're sketching the graph, we want the base to be on the x-axis, 4 units to the left of the y-axis. Okay, so if I make some points here, in fact, I'll carry these on. Fill those in. And I understand these distances are not equal. I know, maybe I'll just equal it up like that. 4 units to the left. 1, 2, 3, 4. So our first point on this graph is going to be right there. So that x equals 4. And the point is 4, 0. We know that our arch, or our arc, however you want to say it, is 22 meters wide. So for it to be 22 meters wide, we have to kind of think about where the other 0 will be. It's going to be somewhere over here, but what is that value? How can we determine that? Okay. 22 meters wide, -4. If we add them together, 22, what will we get? 18. Okay, let's think about this. We're saying our first 0 was right here. Sorry, that should be a -4. And our second 0 is potentially 18 and 0. So, if I count this out, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 13, 14, 15. Oof, I'm going to run out of space. So, I'm going to draw a couple more points in here. I know the graph isn't going to be entirely accurate. Let's just put that there and call this 18. So this point will be 18 and 0. Okay? Now, get rid of that jazz there, just to free up some space. Knowing this information, I kind of want to be able to find my axis of symmetry, which is also known as midpoint. Okay? How do I do that? I look at my zeros. My zeros right now are 4 and 18. The midpoint between, oh, sorry, I keep getting that wrong, -4. Midpoint between -4 and 18, what we're going to do is we're going to add those two together. We're actually going to take the average. So, -4 plus 18 should give us, this is going to be divided by 2, so that's going to equal 14 over 2, which is equal to 7. So, my midpoint is at 7, 0. And we're going to say, let's count it out a bit, 1, 2, 3, 4. Let's say that's right there. And that distance to that distance looks pretty even. So I'm going to roll with that for now. Now, we also know that our arch is 22 meters wide based on what the question, 20 meters tall based on what the question told us. So that part there, ignore that. We need this part here, 20 meters tall. So if we count these out, let's make these 2 each. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. 20 and 7 should be about there. And this point, oops, it's going to be 7 and 20. So, I know this is my midpoint. I know this is my vertex. And I know these are my zeros. So what I can do before I go any further is actually find my y-intercept. It's one thing I haven't found. So I don't even know if I need my y-intercept at this point, do I? Probably don't, if I'm honest. I'm actually going to skip the y-intercept, but basically all you would do is use vertex plus zeros plus factored equation to find y value. But I'm going to skip this. I can do it another time, just in the interest of time, because we're already at about 9 minutes. So, make it really simple. This point needs to connect through here. That point needs to connect through there. Okay, and that's what our graph would look like. But because it is an arch, we actually don't have a full-on graph. Just looks like that. Alrighty. Yep, that's all we're going to do for that section. Getting into more application word problems. So, Mr. Benjamin's music store. Oh, I just erased all that. Right here. Currently charges $10 per CD and sells an average of 80 CDs per week. Now, realistically, if I had a music store that sold 80 CDs a week at $10 per CD, I probably wouldn't be teaching, but, I digress. If he increases the cost, it's addition, cost of the CD by $1, he sells 5 less CDs per week, which isn't ideal, but we want to know at what price will he maximize his revenue. Things I want to point out here. Okay, $10 per CD is a value we need to know. 80 CDs per week is a value we need to know. Sorry, I'm just getting a call from Quebec, apparently. I'm going to ignore that. If I increase the cost of the CD by $8, so that's $1, I sell 5 less CDs per week. So as the price goes up, the number sold goes down. So it's an inversely proportional relationship. So how are we going to decide, or how are we going to establish what our revenue is? Not sure why that's not erasing. Okay. First thing I want to do is assign some variables. I'm going to say let R equal revenue. I'm going to say let X equal price change. Okay. Now that I have my variables, we can determine a couple of equations. R, revenue, is going to be equal to number of CDs sold multiplied by the price. It is also, well, not also, if I actually work that out, it'll be 80 subtract 5x, because we said x would be the price change, multiplied by 10 plus x. So every time we change the price, we go up by 1. And you know what I'll do is I'll put a 1 here to make it kind of more visible that every time we change, we're going to add a 1. Okay. So I'm going to take these two equations. I'm going to copy them over here. So at this point, nothing's changed. Our revenue is still equal to, well, put an R there as well. R is equal to 80, subtract 5x, and 10 plus 1x. We need to find a way to find out this value, whatever x will be. X is equal to price change. And R is equal to revenue. And we want to know is, or what we want to know is, what is our max revenue? That maximum, that should give you a hint. That should tell you that we're going to have a graph that's going to have a parabolic relationship. And that value right there is going to be the best price to sell. Selling price. Oh, that looks terrible. I'm going to write it again. Okay, so we need to graph this parabola. If we look at our equation here, we have 80 subtract 5 and 10 plus x. So if we set both of these values to 0, we'd actually be finding our zeros, right? So 0 is equal to 80 subtract 5x. And we also have, 0 equaling 10 plus 1x. If we work this out, we'll get 5x equaling 80. And x should equal 16. If I have this side here, 0 is equal to 1x, so x is equal to negative 10. Okay, so my zeros are going to be 16, 0, and negative 10 and 0. Okay, so my graph would look a little something like this. 16, negative 10. And it's going to have some form of parabolic relationship. We don't know what that is yet. So I'm going to leave that part blank. Because I'm going to try to. There we go. I know my zeros, so from this I can find my midpoint. I'm going to go to the next slide. So, 16, negative 10, average, finds midpoint. 16 plus negative 10. All this divided by 2. This should be 6 divided by 2, which is equal to 3. So, midpoint occurs at x is equal to 3. So to do that quick graph again, this is my negative 10, this is my 16. My positive 3 is about here. So we know that my midpoint is going to look something like this. My graph will be somewhere around there. We have our midpoint. We have an equation. I can now find my vertex, which is also known as my max value, or optimal value. Okay. If I were to take my original equation, r is equal to 80 subtract 5x and 10 plus 1x. Multiplied by 10 plus x. I'm just going to write it at this point. And I sub in my midpoint for, nope, not for r. Undo. Oh man, it's a disaster sometimes. For both of these x's, I should get an r value. And I'm using that value because we know that my midpoint is 3. So r is equal to 80 subtract 5, 3 multiplied by 10 plus 3, which is equal to 80 subtract 15 multiplied by 13. What I should end up with after you do that math, and keep in mind this is in a bracket too, which is important. That's 65 and that's 13. This should equal around $845, I believe. This $845 is my total revenue. It's $845 when CDs sell at $13. So we found our max value. And I'm not going to graph that because 845 is a bit too high for me to graph. But we know the CD sells at $13 because it was 10 plus 3. And our max revenue is 845. We are getting pretty high into the timing on this video, but I'm going to keep it on, trying to get this last question done as fast as I can. The flight path of a rocket is defined by the relationship h is equal to negative 2 multiplied by d subtract 3 multiplied by d subtract 15. Where d is the horizontal distance and h is the height, in meters. Question is, sketch the graph with all important information. So that'd be vertex, zeros, max, /min, etc. How far is the rocket when it hits the ground? Well, that's going to be based off your zeros. Okay? Let's solve that now. We'll have d subtract 3 equaling 0. And d subtract 15 equaling 0. And the answer for those would be 3 and 15. So I'm assuming, because of the horizontal motion, which is this way, it's going to be 15 meters. And the last part is, what is the maximum height of the rocket? Okay, well, maximum height, that means we have a graph, and there's going to be a max like that. So why don't we draw our graph here? We just found our zeros. 3, 0, 15, 0. So that's going to be, let's draw this again. Give myself some more space. Okay. From our zeros, we can always find our midpoint. which would be 3 plus 15 divided by 2. Keep in mind midpoint is average of zeros. This is also known as axis of symmetry. Okay. 3 and 15 divided by 2, so I should have 18 divided by 2, which equals 9. So, midpoint is 9, 0. That's going to be right there, 9. So whatever our graph looks like, whatever my max value is, which I'll probably find next, it's going to be something like that. I'm going to get rid of those two lines, because we don't know that yet. What I want to find now is max height, which is also known as vertex, also known as optimal value. What I'm going to do is sub in my midpoint. Now, I don't have enough room on this slide, so I'm going to go to the next, but what I'm going to first do is look at this equation again. So h is equal to negative 2 multiplied by d subtract 3 and d subtract 15. And I'm actually just going to copy. It'll be a lot easier at that point for me. Alright, done. Sub in midpoint for x to find max height. And remember, that's because our parabola 3, 15, 9. The midpoint of our parabola is at 9, meaning our graph's going to look something like that. So h is equal to negative 2, bracket 9 subtract 3 multiplied by 9 subtract 15. Negative 2 multiplied by 6. It's just solving the work here. And I believe that's negative 6. So I should end up with a positive because I have two negatives. 36 here multiplied by 2, that's 72. And that's in meters, I believe. Therefore, max height of rocket is 72 meters. Up at 9 meters, we'll call it east. So if the rocket's starting here, it's going to go up, and it's going to hit a maximum point of 72, and it's going to start coming down. I'm going to say thank you for watching. Hopefully it was helpful. And I hope everyone has a blessed day.